Hello dear students, welcome once again to my channel Maths in Minutes with Priya. Today our topic is HCF and LCM part 3. If you have watched already part 1 and part 2, you must be remembering what we learned. We learned the basic concept of HCF and LCM, few short tricks, as well as we learned the proper method of finding HCF and LCM using factorization. If you haven't watched these both parts yet, please do watch them before part 3. Because in part 3, we are going to use some of the concepts that we learned in part 1 and part 2. Then let's begin with part 3. In part 2, when we did the factorization, what was our last step to find HCF and LCM? For HCF, we copied all common bases and we raised them to the lowest power. Do you remember? And for LCM, what we did? We copied all common as well as uncommon bases and then we raised them to highest power. That is HCF and LCM part 2 video. Please do watch it. Now today we are going to learn some shortcut tips. Because during competitive exams, you hardly get any time to think and you hardly get any time for the big steps. So what we are going to do today? We are going to learn the shortcut tips. But as a teacher, I believe that you should know the proper procedure. Shortcut is the next thing. Shortcut is not the first thing. So in part 2, I have covered the proper method. In part 3, I am going to cover the shortcut methods. If you are a school child, you may not be allowed to use shortcuts, but still you can watch this video to increase your speed. If you are allowed to use that in school, then good for you. So let's begin. Now I am asked to find HCF and LCM of 49, 45 and 352. When I factorized, what I found is there is no common base. 2 is here, 2 is not here. 3 is here, but it is not here. 5 is here, but not here, not here. 11, not here, not here. So there is no common base. For HCF, what we require? We require to copy the common bases to all 3 and then raise them to highest power. But since there is no common base, our HCF is 1. And for LCM, what we do? We copy all common and uncommon bases and raise them to highest power. But there is no common base, only uncommon base. So we need to copy everything and take their product. So LCM becomes the product. Since I have to copy everything for LCM. So that means when there is no common factor, there is no common base in all 3, HCF becomes 1 and LCM becomes the product. If in a set there are all prime numbers only, I am asked to find HCF of 17, 7 and 11. Do you observe all 3 numbers are prime? That means their HCF, their highest common factor is 1 and LCM will be their product 17 into 7 into 11. That is the rule for prime numbers. In a set, if all numbers are prime, then HCF is 1, LCM is product. Let's see one more example. We are asked to find HCF and LCM of 89, 19, 23. All 3 are prime. See, all should be prime. If all are prime, then their HCF is 1 and LCM is the product. Straight away, you can conclude this. HCF is 1, LCM is product. Do you understand both these concepts? These numbers are not prime, but there is no common base. So HCF is 1 and LCM is product. These numbers are prime. So HCF is 1 and LCM is product. Sometimes there will be combination of prime numbers and composite numbers. So you need to see how to factorize those composite numbers and if any prime number is a factor of that. That type of examples we have covered many. So You will already find them. This is just for different cases, that if these are all composite and still no common factor, these are prime, so naturally no common factor. Now let us go to the fast methods, to the shortcut methods. 20, 30 and 70, find HCF and LCM. I have purposely taken an easy example to explain the concept. Later on we will move to some difficult examples as well. So 20, 30 and 70. See what we are going to do now. We will write this 20, 30, 70. Like this. Now when I look at this number, the very first common factor that comes to my mind is 10. They are all divisible by 10. So what I'll do, I'll divide all by 10. This is 10 2s are, 10 3s are and 10 7s are. Now is there any common factor between these three, 2, 3 and 7? There is no common factor between 2, 3 and 7. So you can stop here. This vertical side becomes your HCF, and product of this vertical side and this horizontal side becomes your LCM. So HCF is 10 and LCM is 10 into 2 into 3 into 7. That becomes 420. So what we did? We found out common factor until there is no common factor between all of them, neither two of them, no common factor. Then we stop here. This vertical becomes HCF and this vertical into horizontal becomes LCM. We are going to see many more examples covering all possibilities. So right now just remember this. Vertical is HCF, horizontal is horizontal multiplied by vertical becomes LCM. One more example. Now I need to find HCF and LCM of 84, 168 and 144. When I look at these three numbers, the first factor that comes to my mind is 12. 12 sevens are 84 and 12 square is 144, and when I divide this by 12, this is also completely divisible. So I wrote 12 here. 12 sevens are, when I divide this by 12 I get 14. When I divide this by 12 I get 12. So all three numbers are divisible by 12. Now between these three, do you see any common factor? Between 7 and 14 there is common factor of 7. Between 14 and 12 there is common factor of 2. I agree. But when I consider all three together, is there any common factor? All three together I am talking. When I consider all three together, there is no common factor. So I am going to stop here. This side becomes my HCF. HCF is 12. I am going to stop here for HCF. But for LCM, I cannot stop because there are some common factors here and here, here and here. There are some common factors. So next common factor I am going to observe is between 7 and 14. It is 7. When I divide by 7, I get 7 ones are, 7 twos are, 12 remains as it is. Now between 2 and 12, again 2 is a common factor. Now this becomes 1, this becomes 1 and this becomes 6. Between 1, 1, 6, there is no common factor. 1 is the common factor which is factor of every number. So that means there is now no common factor. So now I'll take product of this vertical side and horizontal side. Vertical side is 12 into 7 into 2. Horizontal side is 6 and product is 1008. That is the LCM. So for HCF, where did we stop for HCF? We first found a common factor 12. When we divided, we got 7, 14 and 12. Between these three, there wasn't any common factor and hence we stopped for HCF. HCF becomes 12. Now I am going to cover the same example here for a different purpose. See, our first step was this, that is fine, that you already understood. And I stopped here and I concluded that my HCF is 12. But next step what I did, I found common factor between 7 and 14 at 7, and hence I took common factor 7. But what if instead of taking common factor first here, I took a common factor first here. See, 14 and 12, they also have one common factor, which is 2. So first I took common factor 2. Instead of 7, I have taken 2. So 7 will be as it is. This will be 2 7s and this will be 2 6s. Now between 7 and 7 there is common factor 7. So 7 1s and 6 remains as it is. So again you can see HCF is same 12 and LCM is what? Vertical side 12 into 2 into 7, horizontal side into 6. So this is same 1008. So if you take 7 first or you take 2 first, doesn't make any difference. Your final answer remains the same. Now I am going to suggest you one more shortcut for HCF. But remember, whatever now we are going to see, it shouldn't be used for finding LCM. This is shortcut for HCF. This method should not be used for LCM. You getting it? Let us see what is that shortcut. Shortcut for HCF. Ignore multiples if you notice any. Again I am taking the same example, the earlier one which we saw here. I am again taking the same example, 84, 168 and 144, and this method tells me ignore multiples if you notice any. Here I notice a multiple, 4 2s are 8, 8 2s are 16, that means 168 is 84 multiplied by 2. 84 multiplied by 2 is 168, that means 168 is a multiple of 84. 144 is not multiple here, but 168 is a multiple, and they say if you want to find HCF, straight away ignore the multiple. So right now I am going to ignore it. Now I am left with only two numbers, 84 and 144. Between them 12 is a common factor. 12 7s and this is 12 12s. I have ignored this. 12 7s and 12 12s. There is no common factor between 7 and 12, so I am going to stop here and my HCF becomes 12. My HCF becomes 12. Remember, don't use this method for finding LCM. Don't use this like this, that now horizontal into vertical now becomes LCM. No. Since you have ignored this LCM, you shouldn't use this method for finding least common multiple. Are you getting it? So your HCF is 12. You have ignored this number. Still the HCF remains the same. This is the shortcut for HCF. But sometimes what will happen? You are in very much hurry during exam. You won't notice that this is multiple. You won't notice. Then also doesn't matter. You can stick to this. See, here we haven't ignored anything. Same example I have taken. Same example. Here we haven't ignored anything and still we got our HCF as 12. Not a problem. But by chance, if you are able to notice it, you will save your time by ignoring this. Is it clear? Now let's solve few examples based on this trick. Now we are going to find HCF and we are going to ignore multiples if we are able to notice. We need to find HCF of 12, 24, 48 and 90. Do you observe any multiples here? 24 is a multiple of 12. I am going to ignore it. Since I want to find HCF, I am going to ignore it. 48 is multiple of 24 also. 48 is multiple of 12 also. I am going to ignore it. So I'm going to I'm left with only two numbers, number 12 and number 90. Is there any common factor? Yes, 6 2s are 12 and 15 6s are 90. So 6 is a common factor. This is 2 and this will be 15. Between 2 and 15, is there any common factor? Between 2 and 15, there is no common factor. So I'm going to stop here. This becomes my HCF. Remember, this 6 is HCF of all four numbers. This 6 is HCF of all these four numbers, but I ignored for 24 and 48. Even if I had taken 24 and 48, HCF will be 6 only. But to save time, I have ignored 24 and 48. I just took into account 12 and 90 as per my shortcut trick, and I found HCF 6. One more example, 54 and 108. Now between 54 and 108, I observe that 54 multiplied by 2 is 108. That means 108 is LCM, 108 is multiple. So what I am going to do? Since I am asked to ignore multiples, I am going to ignore it. So I have left with 54. That means HCF of these two numbers is 54. Next example, 42, 21, 60 and 12. What do I observe here? 21 2s are 42. This is multiple. 12 5s are 60. This is also multiple. 21 and 12, right now they are not multiple of any number in this list. So I'm left with 21 and 12. I notice 3 as common factor. 3 7s and 3 4s are. 7 and 4 do not have any common factor. So 3 becomes my HCF. My HCF is 3. Did you get this shortcut? We ignored the multiples. But again let me repeat this. Don't use this method for LCM. This is only for HCF. Next example. 1008, 3024, 144. 8 3s are, see, this is 10,008, 08, this is 8 3s and 10 is 10 3s are 30, 8 3s are 24. So when I multiplied this by 3, I get 3024. I noticed it. By chance I noticed it. Thus this multiplied by 3 is this. That means this becomes multiple, so I am going to ignore it. Then I copy this. When I look at 144, it is 12 square, so I must know whether this is divisible by 12. When I divide this by, I can either use divisibility criteria of 12, which we have already learned, or otherwise I can directly divide it by 12 and see whether it is divisible. If I divide, what will happen? 12 8s are 96, 4 remains 48, 12 4s are 48. So yes, this is divisible by 12 and this is 12 square, so again 12. Between 12 and 84, 12 is again common. See, now I can't stop here because between 84 and 12 there is a common factor. So I take it. Now between 7 and 1 there is no common factor, so I can stop here. That means my HCF is 12 into 12. Vertical. This is my HCF, 12 into 12, that is 144. See what happened here? 144. This number only turned out to be HCF. Why did this happen? Because 1008 is also multiple of 144, which we didn't notice earlier. If we had noticed it earlier, we would have ignored it and then straight away we would have concluded that HCF is 144, but we didn't notice it, so we tried to find HCF and we found it as 144. Now again Let me repeat this. If you miss to notice any multiple, then stick to the earlier methods. Even if you fail to notice any multiple, it doesn't make any difference. You can stick to our original methods and find a HCF. Copy these three numbers, try to find a common factor, stop when you get no common factor left, or you can also stick to the original method that we learned, the proper technique that we learned in part 1 and part 2. You can use that also. This is just a time saving trick. Don't worry if you miss to notice any multiple. As and when you go on solving many examples, you will automatically start noticing multiple. Your brain gets ready for that. So don't worry too much about shortcuts. Okay? Now let's learn a shortcut for LCM. It's similar to HCF. For LCM, ignore factors if you notice any. This is exactly opposite. For HCF, what we did, when we wanted to find highest common factor, we ignored the multiples, and now we need to find least common multiples, so we are going to ignore factors. Getting it? So the methods are similar. For HCF, you ignore multiple, and for LCM, you ignore factor. But again, this is same. You can't use this for HCF. This is only for LCM. Remember, with this method, you cannot find HCF. Since you are ignoring factors, you cannot find HCF. You can only find LCM through this method. Again, I'm taking this example. Ignore factors if you notice any. Now when I look at these three numbers, 84, 4 2s are 8, 8 2s are 16. That means this multiplied by 2 is 168. That means 84 is a factor. 84 is a factor of 168. So what this shortcut says, since I want to find LCM, I'm going to ignore the factor. So now I'm left with only two numbers, 168 and 144. 168 and 144. One 144 is 12 into 12. Let me see if this is divisible by 12. 12 ones are 4. 4 remains 48. So 12 fours are 48. And this is 12 12s. Can I stop here? No, because for LCM we go on till we have the common factor. So 14 and 12 there is common factor 2. 2 7s are and 2 6s are. Now between 7 and 6 there is no common factor. For LCM it is vertical multiplied by horizontal. So 12 into 2 into 7 into 6, which comes out to 1008. Remember, this 1008 is LCM of all these three numbers. We have ignored 84, but still this is LCM of all three numbers. This is shortcut for LCM, ignore the factors. Let's see one more example. 12, 24, 48, 90. Are there any factors here? 12 is a factor of 24. I'm going to ignore it. 24 is also a factor of 48. I'm going to ignore it. I'm just ignoring the factors. So I'm left with 48 and 90. I observe 6 is the common factor. 6 8s are and 15 6s are. Now between 8 and 15 there is no common factor. That means I have to stop now. LCM is vertical into horizontal. 6 into 8 into 15, which comes out to 720. 720 is the LCM. One more example. 54 and 108. I have to find LCM. It says ignore factor if you notice any. 54 multiplied by 2 is 108. That means 54 is a factor. I'm going to ignore it. I'm left with just one number, and that becomes LCM. So 108 is LCM of 54 and 108. One more example, 3, 4, 6, 8. Here I have purposely taken very small numbers because what happens is one student get used to find HCF and LCM of big numbers, they forget how to deal with small numbers. I have observed it, and that's why I have taken these small numbers, and you are going to need small numbers often in word problems. So let's see this. Now I need to find LCM. So what I must do? Ignore the factors. 3 is a factor of 6. Ignore it. 4 is a factor of 8. Ignore it. So I am left with 6 and 8. 2 is a common factor. 2 3s are and 2 4s are. 3 and 4 do not have any common factor. So I have to stop here. LCM is 2 into 3 into 4. 24. 24 is the LCM. Now big number. 1008, 3024, 144. I notice that this into 3 is this. This number into 3 is this. That means this is factor. So I must ignore it. I can ignore it. I am left with these two numbers. This is divisible by 12. So I am trying if it is divisible by 12. 12 6 12 2s are 24, 6 remains, 6 and 2, 12 5s are 60, then 2 remains 24, 12 2s are 24 and this is 12. This is divisible by 4, this is also divisible by 4, 4 6s are and then 4 3s are, and this is also 4 3s are, again 3 is common factor. This is 21. And this is 1. So now my factors are over. My LCM is this 12 into 4 into 3 into 21, that is 3024. The product is 3024. This is LCM of these three numbers. So do you observe same number has appeared here? Why this happened? Because we ignored this being a factor, but 144 is also a factor of 3024 that we didn't notice earlier. If we had noticed it earlier itself, we would have ignored it then and there, and in 1 second we would have concluded that 3024 is LCM. But never mind, it wasn't possible for us to notice that this is also factor, so we copied it and we found the LCM. So if you have noticed that even if we fail to notice factors and multiple, still we can get HCF and LCM right, not a problem. But by chance, if you are able to notice them, you will save lot of your time. So now, so that same I have written here. If you miss to notice the factors, then stick to earlier methods, no problem. Now we are going to HCF of fractions and LCM of fractions. In fractions, I think you know already, 3 upon 4 is what? The number above this line is known as numerator, hence I have written here n, and number below the line is denominator, hence I have written d. Here also n and d. Instead of writing numerator and denominator, I have mentioned them as n and d. HCF of fraction is HCF of numerator upon LCM of denominator. If you see HCF here, write HCF here and LCM in the denominator. LCM of fraction is LCM of numerator, HCF of denominator. LCM here, down is HCF. Very easy formula to remember. LCM of fraction is, HCF of fraction is HCF of numerator upon LCM of denominator. LCM of fractions is LCM of numerator upon HCF of denominator. Now I need to find HCF of 3 upon 4, 2 upon 3 and 5 upon 6. So what I need to do? HCF of this fraction, so numerator I need their HCF. So HCF of 3, 2 and 5, that will be in my numerator, and denominator will be LCM of this 4, 3 and 6. LCM of 4, 3 and 6. Very easy. HCF of these three numbers is 1. LCM of these three numbers is 12. So answer is 1 by 12. Now I need to find HCF of 7 upon 8, 21 upon 25 and 14 upon 50. HCF, I want to find HCF, so it will be HCF of numerators, HCF of 7, 21 and 14 upon LCM of 18, 25 and 50, which come out to, this comes out to 7, this comes out to 200, so answer is 7 upon 200. LCM of 3 upon 4, 2 upon 3, 5 upon 6. So now I have to find LCM. That means LCM of numerators I should notice. LCM of 3, 2 and 5, and denominator will be HCF of denominators 4, 3 and 6, which comes out to 30 upon 1. Next, LCM of 7 upon 8, 21 upon 25, 14 upon 50. That means LCM of 7, 21 and 14 upon HCF of 8, 25 and 50. This comes out to 42. This comes out to 1. So this is 42 upon 1, that is 42. 30 upon 1, that is 30. 42 upon 1, that is 42. I've covered here 4 examples. They are very, very easy. The main thing you should know is to find HCF and LCM. That is the main thing. Once you find it, the formula are very easy. Is it clear? This is end of our part 3 video of HCF and LCM. From next part, I am going to solve the word problems. We are going to solve the word problems, but by then you should be an expert in finding out HCF and LCM. So keep watching these 3 parts and keep solving the problems. For word problems also, I am going to cover all the variety. There is variety of problems for HCF and LCM. So I am going to cover everything of that. So keep watching. If you haven't yet subscribed to my channel Maths in Minutes with Priya, please do so. Don't forget to hit the bell icon so that you can get notification whenever I post new videos. Give your likes, comments and suggestions. So see you in the next part. Till then, be happy, keep learning, stay blessed. Bye for today.